Hey folks, today I wanted to look at an example of the type of problem you might see involving resistance and resistivity on the AP exam. Now you'll notice if you look at the green sheet that they don't actually give us that equation for resistance and resistivity. So they're expecting that we have some understanding that the resistance of this resistor depends on the material it's made out of, which goes with that resistivity quantity. And it depends on the geometry of that material, the geometry of the object. In particular, it's proportional to the length, the resistance is proportional to length, and inversely proportional to the area. So they don't give us the equation, but they ask that we know something about what causes that resistance. So smaller area means more resistance, and bigger length means more resistance as well. So while they won't give us any equations where they ask us just to calculate resistance based on resistivity and area and length, they probably will ask us to compare a couple of resistors, or maybe put this in the context of an Ohm's law question, which is learning goal 9D for us. So let's take a look at a simple version of a problem like what you might see on the AP exam. We've got two resistors, and I'm just going to start writing down information on these two resistors. So I'll call these just 1 and 2. And so resistor 1, I'll say, has resistance R, and resistor 2 then is 10R. They both have the same length. I'll call that L and L. And we're looking for the ratios of their diameters. So let's call this one D, and this one some unknown diameter. Okay, now the resistance equation says resistance equals the resistivity times the length divided by the area. I guess one piece that I should include here is that we do know that they both have the same resistivity because they are the same material. So some resistivity rho and resistivity rho on this as well. I'll just write out an equation for each one of these. R equals rho times L divided by A. And this time we're going to have 10R. I need to make sure I get that right. So we can compare these then. So here we have 10 times as much resistance, and the only way for that to happen is if we have 1/10 the area. So we can calculate that as well. So we'll compare the areas, and I'll call this one area 1 and area 2. So I know those two are going to be different. The lengths are the same, the resistivities are the same. The areas must be different then, otherwise we wouldn't have two different values for R. So let's just compare the ratio of the two areas then. So I'll plug in the this R is equal to rho L over A1. I'll put that in for R over here. So I'm going to plug this whole expression in for R, and then I'll have 10 times rho L over A1, and then that's equal to rho L over A2. And write that then as 10 rho L over A1 equals rho L over A2. I can divide both sides by rho, divide both sides by L, and get 10 over A1 equals 1 over A2, or simply 10 is equal to A1 over A2. Okay, so we know that that A1 then has 10 times is 10 times larger than A2. So that first wire has 10 times the cross-sectional area that the second wire does. But how does that translate to diameter? Well, we know that area is equal to pi r squared, or I can write area equals pi times diameter over 2 squared. You might already guess here that basically we're going to end up square rooting this 10 here, so it's not a difference of, or not a factor of 10 for the diameters, but a factor of square root 10. But we can actually plug into this equation to get this result. So let's call this 10 equals, A1 is going to be pi times, we'll call it D1 over 2 squared, divided by, and A2 is going to be pi times D2 over 2 squared. All right, the pi's cancel. The 2 squared on bottom for each one, those cancel. And that leaves us with then 10 equals, we'll have D1 squared over D2 squared. Oops. And if we square root both sides, then we'll have square root of 10. Square root of 10 is 3.16, we'll say, is equal to D1 over D2. Oops, lost my 2 there. So then the result is that that first resistor, the one that has the smaller value for resistance, just R, must have 3.16 times the diameter of that second resistor, which has a value of 10R for resistance. So the thinner the resistor, the smaller the diameter, the larger resistance we're going to get. So the one with the larger resistance is the one with the smaller diameter. You could also write this out as, if I multiply both sides by D2, I could write this as D1 is equal to 3.16 times D2, and that expresses the same thing. So very frequently, rather than have you calculate numbers, they'll have you compare two theoretical or the two hypothetical resistors and just look for a ratio between factors there. Keep in mind that we almost always are going to deal with some regular geometry shape for the resistor. So maybe it'll be a cylinder, so area is pi r squared. It might be a rectangular prism though. So then we could do length times width for the area on that. Just be sure that you're doing the cross-sectional area rather than the area of one of the faces on that. So something to watch for on that. Thanks very much for watching. If you learned something from this video, by all means like and share this. If you think you might learn something from future videos, I'd encourage you to subscribe to the channel. Thank you.